Alright, I'm going to do a Unit 8 review video. I'm going to do it all in one because this unit's actually pretty short, and hopefully not the worst unit ever. I'm going to start with SCP-6 because I know that's what a lot of people have asked me to sort of talk about in terms of review. Really, when we're dealing with pendulums and springs and simple harmonic motion, there will be on the test asking you, like, how does each variable affect the period? So here I've written, my physics teacher did this, I've written every, so pendulum spring, and I've written every variable in the, equations, right? And what could affect, and I started the period, what could affect the period here? So you could, so there's 1, 2, 3, 4, 5, 6, 7, 8 different explanations. You can, or is that 7? There's 7 explanation like they could ask you, how does length, and I'll cross this one out too, because length doesn't, G and L don't really affect for spring, but 6 different kinds of explanation. How does amplitude for a pendulum affect the period? How does spring constant for a spring affect a period? So they could really ask you any 6 of these on the test, so, be ready to explain that kind of stuff, right? And another thing is, they might not even ask you to do it in terms of forces. So for example, let's take, how does mass affect the period of a spring? Here's how I'll do an explanation. So for mass, right, more mass, when you increase the mass, the spring force, right, at the amplitude, so maybe this is the equilibrium, at the amplitude, it should really be the force spring is the same because F spring equals negative kx. So the force is the same. F net, which is force spring, equals ma. You have the same force for a greater mass. That's going to result in less acceleration. So less acceleration, but the distance is the same. And just sort of explaining it like that, you're going to have a higher period. They might not ask you to do with forces. They could say, explain how mass affects the period for a spring in terms of energy. So then you got to be like, okay, it's kind of a similar explanation, but instead of forces, U spring stays the same. Because U spring equals 1/2 kx squared, right? The mass doesn't change how much elastic potential energy there is, because it's the same stretch and the same k, so mass doesn't change that. Because of conservation of energy, no outside forces doing work, we know that U spring is going to equal kinetic energy. So 1/2, or I'm not going to do it with math, but if you have the same amount of energy and k equals 1/2 mv squared, this U spring is going to transform into k. It's the same amount of U spring, so the same amount of k regardless of your mass. So if you have a greater mass, you're going to have a lower velocity. Hopefully that energy explanation kind of makes sense, because they could ask you that. They could ask you, how can you explain these things with energy? But in terms of SCP-6, this is kind of the key conceptual parts. I'm sure the test won't just ask you, how does this affect the period? How does this affect the period? There could be questions. I'm trying to think of an SCP-6, 6 on the spot. Maybe they could ask you trying to think. I saw a problem in the practice test. I was like, okay, what happens for as a spring approaches, so as it approaches equilibrium, what is happening to its velocity and what is happening to its acceleration? So you got to kind of talk about what's happening, right? We know if I were to approach a problem like this, we know that the acceleration is decreasing because as it gets closer to equilibrium, the stretch is getting less and less, and force spring is equal to negative k change in x. So if your force spring is decreasing, F net equals ma, your acceleration is getting smaller. And because there's a force, but there's still a force, right? There's still a force. There's always going to be a force until right here, because that's when the force is 0, right? Because that's when there's no stretch. So because there's a force in the same direction as the motion, the velocity is increasing, because And you can kind of tie this back to energy. The force is in the same direction as velocity. You're adding energy. It's getting faster. So that's kind of a weird explanation, right? Because the acceleration is decreasing, but the speed is increasing. So it's like, back to that practice test, just thinking through things like that. Like sometimes you don't know what you're going to get in SCP-6. That's kind of the sad, scary truth. Because you know there's going to be stuff like this, but there could just be some explanation that I can't even come up with, some explanation problem. So just try to conceptually understand everything. Understand what is a restoring force, right? A restoring force is a force that points back to equilibrium. So if your spring is here versus if your spring is, I drew this spring horribly, but if it's to the right, then it's going to point to the left. And just understanding conceptually what is restoring force, what is period, like what is it, like what, even stuff like what is acceleration, like just understanding all of that stuff will help you form better explanations. So I think that's really all I can say in terms of SCP-6 review. Just remember some key things like restoring force. I just said this, it's a force that points back to equilibrium. For a spring, it's going to be your force spring X. For your pendulum, let me just sort of make this a dotted line. For your pendulum, it's going to be, if you have FG, FT, it's going to be the FGX, so you can always talk about FGX as a restoring force. It always points back to equilibrium, so as the pendulum swings here, and then it swings back, and then swings back, it'll always point back to equilibrium, always. You can talk about, I think that really is what SCP-6 boils down to. Just remember the stuff like restoring force. Remember, just how simple harmonic motion works. A back and forth motion, I think you'll be fine. So let me check what time I'm at. 7:13. Okay, I'm going to write down on my board 7:13 so that I can add the timestamps later on. Let's go on to SCP-4. I think SCP-4 is pretty straightforward, this unit. There's a couple things to remember. So keynotes, you'll get a scenario and you have to draw all the graphs, right? You have to draw what each graph is and stuff like that. I'm not going to go through you can watch my past videos. I kind of walked through how to do those kind of graphs. You can check out worksheet 3, just pendulums. I did a whole walkthrough. Just remembering okay, if the scenario says that the spring starts to the left, so if it starts at negative A, right, it starts to the left, remember, your position versus time must start in the negative, right? And then it goes to equilibrium, then it goes to positive A, and then it goes to so on and so forth. You get your graph, okay? I would always recommend just starting with your position versus time graph. I think that's usually the easiest, because once you have your position graph, now you're just graphing slope. The slope here is 0. The slope here is positive. The slope here is 0. The slope here is negative, right? And then you're just graphing that for velocity, and then same thing for acceleration. I think we've done this a lot, so I really hope this kind of makes sense to you. Hopefully, I think it just boils down to practice, just sort of understanding how slope and how those things are connected. I think that's pretty straightforward. Some other problems. So just remembering how to linearize. So if they give you period versus length, okay, for what do you call it, pendulum. To linearize it, you're going to do t squared versus L. What is the slope? The slope is 4 pi squared over g, right? And then if they ask you what is the g, let's say that, here's a graph, figure out the g on this planet, you would use the slope. Don't memorize the slope as 4 pi squared over g. Just go back to your equation. T squared equals 4 pi squared g over L. Where does this come from? It's just t equals 2 pi square root L over g. In fact, I'll do something like this. 4 pi squared L over g. Now you're just taking the square on both sides. Remember that. Remember all that kind of good stuff. let's see, what else in terms of SCP-4? Using the slope. Energy. One thing that people tend to forget about energy graphs, if you had K, so let's say for this scenario, K versus T, and then you're doing one full period, remember, it's going to have, so initially, 0 kinetic energy. At equilibrium, it's going to have full kinetic. Another amplitude, you're going to have, no kinetic energy. At equilibrium, you're going to have all your K, and then at negative A, they're going to have, no kinetic energy. For one period, there's 2 peaks. And that kind of makes sense. Like, I know here there's only 1 peak. For one period, there's 2 peaks because in one cycle, it goes through equilibrium 2 times. So that makes sense. Like, it makes sense why there'd be 2 peaks. Now, obviously, you could have it, like, starting here, and then you could have some real, funky stuff. But still, the whole point is just understanding that this is where equilibrium, this is where it's stretched. Stuff like that. With that in mind, I'm probably just going to head to SCP-5. I don't know if there's much to SCP-4. I'm just looking back at the quizzes. It's really just graphs. Just trying to conceptualize these graphs. I'm going to head over to SCP-5 now. What time are we at? 11:23. Sorry if this is rushed. I actually have stuff to do after this, so I'm trying to go through this a bit faster than usual. So, let's see, SCP-5. Really, just remember, T period equals 2 pi square root L over G. T spring equals 2 pi square root M over K. Don't memorize. Don't try to memorize. Okay, mass always cancels out and it doesn't affect the period. True for the pendulum, not true for the spring, right? Or you could say like, oh, length is not in the equation. Yeah, you're right, not for the spring, but it for sure is here. So don't memorize the equations. I'm not expecting you to like know the calculus and derive them, but stuff like, you have an equation sheet. Don't rely on your memory. If you really don't know, just go to the equation sheet. This is like the one unit where I do find myself going to the equation sheet a lot, because I don't, like off the top of my head, I don't know, like is it 2 pi, is it 4 pi squared, stuff like that. Like, it just helps to go to the equation sheet for that kind of stuff. So yeah, you can do a whole bunch with these equations. Sometimes, like, okay, I don't know the test, but maybe they'll ask you something like, okay, like if you have a grandfather clock, those work by having a pendulum, right? There's a pendulum in here, and it, after one swing is going to count towards 1 second, right? So what is the length of the pendulum, right? For a grandfather clock, what is the length? You just have to use the equation. Tp equals 2 pi square root L over G. They don't, we're going to assume we're on Earth, so we can just put 9.8 here. For the period, it's actually not, for a grandfather clock, it's actually not 1 second, it's actually 2 seconds, right? Because one swing, right? If you swing once, that's half a period. You have to swing back again, 2-second period. And then you can figure out the length, right? By just algebra. If you're curious, the length is actually, for any grandfather clock, it'll always be 0.992 meters. That's pretty interesting, because that's just how pendulums work. They use the physics of pendulums. So they could definitely ask about this. You could derive stuff, proportional reasoning, right? Understanding that this is inside the square. So if you if you increase this by 4, then the period increases by 2, because when you take the square root of 4. When it comes to proportional reasoning, I don't like doing it with this equation. What I like to do is I like to square everything beforehand, and then use the squared version. T squared equals 4 pi squared L over G. For me, I just prefer it because then I can say, okay, L becomes 2 times, so this needs to become 2 times, and then I can put this inside the square, and then I realize, oh, it's like that. It's up to you, though. I think actually this could be easier. It just depends on how you think through it. So proportional reasoning, deriving, you can derive an equation. So if it's like, ask for if it's like, yeah, you derive an equation, yeah. I don't think there's much to say. If it's asking for g, derive an equation for g in terms of those variables, I think that'll be pretty straightforward. Remember that sometimes I've seen problems with like max acceleration. So like the spring has a max acceleration of 10 meters per second squared. What does that mean? Well, that means that, so if you had a spring, right? The force of the spring is equal to the F net, right? That's like the only force on the spring. So force of the spring is going to equal negative kx is going to equal ma. So when this x is at a maximum, so if this is at a maximum, the acceleration will be at the max acceleration. When is x at a maximum? Like when is the stretch, like the most stretched? It's at the amplitude, right? That's where it's going to be the most stretched. You would just plug in a here, and then you can actually figure out like the max acceleration. I saw a problem like that, so I just thought I'd mention. But that's really it in terms of SCP-5. I think SCP-5 this unit has been very manageable for a lot of people. So yeah, I guess there's no point in putting that in. But yeah, that's basically it. That's everything you really got to know. Good luck on tomorrow's test. I hope everything goes well. And I hope you don't need any luck, because you're just good at this stuff. Alright, see ya.